Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 1, Section 1, titled Using Variables. By the end of this video, you will have reviewed methods for modeling relationships with variables, equations, and formulas. You will review the writing of algebraic expressions and equations, and to that end, you will look at a real-world problem that explores the idea of writing an equation based on a table of data. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find the video to be helpful. Thank you. Okay, so let's start off by reading and discussing some definitions here. A variable. What is a variable? A variable is a symbol, usually a letter, that represents one or more numbers. An algebraic expression. An algebraic expression is a mathematical phrase that can include numbers, variables, and operation symbols. An equation is a mathematical sentence that uses an equal sign. If the equation is true, the two expressions on either side of the equal sign represent the same value. Open sentence. An equation that contains one or more variable is an open sentence. Objective 1. Modeling relationships with variables. If you earn an hourly wage of $6.50, your pay is the number of hours you work multiplied by 6.5. In the table at the right, the variable h, you see it here at the bottom, right here, the variable h, stands for the number of hours you worked. A variable is a symbol, we just saw this. A variable is a symbol, usually a letter that represents one or more numbers. The expression 6.50h, or 6.50 times h, you can think of it that way, is an algebraic expression. An algebraic expression is a mathematical phrase that can include numbers, variables, and operation symbols. Algebraic expressions are sometimes called variable expressions. But the key here is you see that in this little table, they're showing you that h could be whatever numbers you're working. So it could be 40 hours a week, could be 20 hours a week. It's whatever your job gives you and allows you. But that h is the number of hours. And for your pay for that week or month or however you're paid is going to be, and if you're earning $6.50 an hour, then it's going to be $6.50 times h. And that's where you see it here. The expression 650h right there absolutely points out how much money you're going to make. $6.50 for every hour. So in example 1, writing an algebraic expression, write an algebraic expression for each phrase. So 7, here, problem A, 7 more than n. So you see right here, it's written out, 7 more than n is n plus 7. If you have 7 more than n, you've got n plus 7, right? So more than indicates addition. And add, so how do you do that? You add the first number, the first number, 7, to the second number, n. Okay, here it says 7 more than n. Okay, so the difference here for B, the difference of n and 7. So in this case, it's n minus 7. Difference indicates subtraction. So begin with the first number, n, right here, the difference of n and 7, and subtract the second number, the 7. So n minus 7. So let's look at C, the product of 7 and n. In this case, it's 7n, 7 times n. The product indicates multiplication. Product, multiplication. Multiply the first number, 7, by the second number, n. Here, the 7 by n. And then finally, D here, the quotient of n and 7. So in this case, it's n divided by 7. Quotient indicates division. Now here, division and quotient mean the same thing, right? Divide the first number, the n, by the second number, 7. Divide the first number, here's by the second number, n divided by 7. Okay? Okay, example 1, check your understanding. So what do we want you to do here? We'd like you to stop the video and go work these out on your own. And then when you're done, come start the video and then we'll work on them together. And we'll look at the solutions, okay? So I'll wait for you. Go ahead and stop the video, work these out, and when you come back, we'll continue. Okay, I'm assuming you've stopped and worked them out and you've come back. So let's take a look at the first question, A. It says the quotient of 4.2 and C. So what was that? Remember we said you take the first number and the quotient means divide and divide it by the second number. So in our case here, the quotient of 4.2 and C would be 4.2 divided by C. Okay, I think that's pretty straightforward. And if we look at B, it says T minus 7. And in that case, this is subtraction. We know minus means subtraction. And it's the first number minus the second number. So again, that's T minus 15. Okay. Okay, example 2, writing an algebraic expression. To translate an English phrase into an algebraic expression, you may need to define one or more variables first. So define a variable and write an algebraic expression for each phrase. Okay, and it said you could have more than one variable, but in these cases here, it's only one variable. So problem A, write the expression for 2 times a number plus 5. So let's relate that to the English. Let's get something that's related to English. So we say 2 times a number, 2 times a number plus 5, okay? We broke the sentence into pieces. Then, so what is the letter we're going to define? What is the variable we're going to define? We're going to define n as the number. So 2 times a number, we don't know which, 2 times some number. And that number can be A, B, C, Q, whatever. We're going to name it n. And then you're going to add 5 to it, plus 5. So we've defined n, and what do we see? 2 times, here's our 2 times, the dot in between them means multiply. 2 times n, that number that we don't know, whatever the number is, and you're going to add 5 plus 5. So that's converted. We converted the English sentence into a mathematical expression. Let's try B. 7 less than 3 times a number. 7 less than 3 times a number. So relating English to math, or how we're going to break it up, we're going to say 7 less than 3 times some number, a number. Okay? 3 separate little phrases. 7 less than 3 times a number. So we're going to let a in this time, and you can let any number, any variable you want, but we're going to choose a. So let a equal a number. So in doing so, 3 times, so here you say 3 times, right here, 3 times a number. The number is, oh yeah, a. 3 times a, 7 less than, right? 7 less than means you're going to subtract, right? Minus 7. 7, so if I said B was 7 less than 3 times A, it's pretty straightforward. So 3 times A minus 7. Okay, good. Okay, example 2, check your understanding. Write an algebraic expression for each phrase. Let n be the number. So for all 3 of these problems, you can use n. You can pick any number you want, but in these problems, when we work them together, I'm going to be using n. But you could use A, B, C, whatever you would like. So go ahead and, as before, we're going to, basically, I'm going to try to always do this. Stop the video, work them out, and then come on back and we'll work them together. Okay, I'm sure you've stopped it. You've got them all solved. We've got the 3 problems. Let's see what you have here now. For problem A, it says 9 less than a number. So what does that mean? 9 less than a number. Well, the number we're going to say is n. And this expression needs to be 9 less than n. So that would be 9 minus, or n minus 9. Okay? How about B here? The sum is addition, the sum of twice a number, and remember the numbers are n in my case, the sum of twice a number and 31. So it's the sum. Well, you're summing twice a number and 31. So what would that be? That would be twice a number, 2n, plus 31. And I don't like that color, huh? How about you guys? You like that color? How about, nope, still red. Let's take it. Let's get rid of that red. I'm going to do these over again. Let's do that. Let's get this bright blue. See how that is. 9 less than a number. N, that's better. Minus 9. How about B? The sum of twice a number and 31. Sum is adding. So 2 times n plus 31. Oh, that blue is much better. Okay, C, the product. This is multiplication. The product of 1/2 of a number and 1/3 of that same number. And that number is n. We talked about n's, right? So it's half the product. So it's half of the number. So 1/2 n times, parentheses means time, 1/3 n. And you could have written that a number of ways. You could have put parentheses around both of them. You could have put, well, that's probably the safest way to do it. Okay? Objective 2, modeling relationships with equations and formulas. You can use algebraic expressions to write an equation. An equation, as we learned earlier, is a mathematical sentence that uses an equal sign. If the equation is true, then the two expressions on either side of the equal sign represent the same value. An equation that contains more than one variable is an open sentence. In everyday language, the word is often suggests an equal sign in the associated equation. Okay, example 3, writing an equation. Track One Media sells all CDs for $12 each. Write an equation for the total cost of a given number of CDs. So suppose you want to buy 5 CDs or 20 CDs or whatever that given number is. We don't know, but we're going to write an equation to get that number, the value. Okay, so let's relate that to English and kind of start relating it to mathematics, right? So the total cost is, and we said earlier that is usually implies an equal sign, is 12 times the number of CDs bought. Okay, that's our little equation here. So let n equal the number of CDs bought. And you see it's here in purple. N is in purple. Let C, in light green, the C is the total cost. What we're going to sum the whole thing up. We're going to get the product of all of this, right? So we're going to write C. And what is C? The total cost. C is equal to, here's our equals, is 12 times the number of CDs bought. And our equation then is C equals 12n. So C equals 12 times n, the number of CDs bought. Okay, example 3, check your understanding. So you're going to stop the video, hopefully, and try these on your own. And when you come back, we'll do them together, but I'll read them now. Suppose the manager of Track One Media raised the price of each CD to $15. Write an equation to find the cost of n CDs. And B, suppose the manager of One Track Media used the equation C equals 10.99n. What could that mean? Explain that. Okay, go ahead and stop the video, and when you come back, we'll work on it together. Okay, I'm assuming you've stopped the video, and we're going to work on it. So, suppose the manager of One Track Media raised the price of each CD to $15. Write an equation to find the cost of n CDs. Well, we can use this almost the same equation we used on the last slide, right? So, and if you remember, it was the total cost was C, and that equaled, C is, and then it was, last time I think it was $12. This time it's $15 times, I'm going to put a dot in there this time, times N CDs, or C equals 15N. Okay. Suppose the manager of One Track Media used the equation C equals 1099N. What would this mean? What could it mean? Well, it means the same thing it did with C times N. C is equal to 15N. The only difference is here under the 1099 means that the manager is what? Is charging $10.99 per CD. That's it. Example 4. It's a real world problem we're going to solve here. Write an equation for the data in the table. So let's start by looking at the table a little bit. We see the cost of purchase, $20, $19, $17.50, $11.59. Change from 20. Okay. 0. No change from there. $1, $2.50. Let's see what that means here. So we're going to say change equals $20 minus the cost of the purchase. Okay, so that's what they're saying. So when you're making change, right? So if you buy something for $15 and you give the clerk $20, your change is $6, right? So what is that equation? The change equals the $20 that you gave the clerk, $20 you gave the clerk, minus the cost of the purchase, right? So, like I said, if you paid $14 for something and you gave the clerk $20, you'd expect $6 back. So we're going to use two variables this time. That's the key here. On this table, we're using two variables. We're going to let C equal the cost of the purchase, items purchased, and A is equal to the amount of the change. So we're going to write this equation as A, the change, equals $20 minus the cost. So there it is. The equation is A equals 20 minus C. But now the tender, right, what you gave the clerk can vary too. There could be another variable for that. You could be, G for given, the call minus the cost equals the change, right? So you can start doing more and more and more with this thing. Anyway, so that's what this is. Okay, example 4, check your understanding. Again, as you've learned now, I want you to stop the video and try it out. No matter what you come up with, try your best, and when you come back, we'll work it together. But before you stop it, I'll read it to you. It says directions. Write an equation for the data in the chart. And what is the data in the chart? We see we have earned in light green, I guess that is. Maybe that's yellow, I can't tell. And dark green for saved. Okay, not that that's important, but we're just trying to. So you see that there's the person earned $15 and saved $7.50. Or you can read the rest. Go ahead and give it a try. Stop the video and come on back when you're done. Okay, now that you're back, let's go ahead and work this together. We're going to let S equal the money saved and E equal the money earned. So saved and earned, S and E, right? So I'm going to say that the earned is the light green. Light green is the earned amount, and the dark green is the saved amount. So I have S over here in dark green, right here. S is dark green, right here. And the earned is light green. And what is the equation for that? Well, as we can see, that if you earn 20 and you save 10, you're saving half your money. If you earn 25 and save 12.50, you're saving half your money. 30 and you 15, that's half your money. And back to the original one, 15 and 7.50, that's you're saving half your money. So that equation is the amount saved, right here, the amount saved is equal to 1/2 of what you earned. And there's your equation.